Okay, question 3 here. It says the probability that a school bus is late, if it was late the day before, is late, is 0.6 if it was late the day before, but 0.3 if it was not late the day before. Okay, so the probability that a school bus is late is 0.6 if it was late the day before. So we've got basically 2 days going on here, day 1 and day 2. Okay, now it can either be late or not late. Okay, and late or not late. So that's the situation that we've got for this one. And it says the probability that a school bus is late is 0.6 if it was late the day before. So this is late the day before here, right? And if it's late again, then this is 0.6. So this arm here is going to be 0.6. So this is late given the fact that it was late the day before. Okay, so this value here is 0.6. Okay, but 0.3 if it was not late the day before. So it's not late the day before. That's this arm. That's not late the day before, day 1 in other words. And day 2, the probability of it being late is 0.3. So that's that arm there. So this one is going to be 0.3. Now, what do we know that these should add up to? These two arms, they should add up to 1, right? So if this is 0.6, then this arm must be 0.4. We also know that these two arms must be adding up to 1. So if this here is 0.3, then this one must be 0.7. Okay, so that's those sorted out. Given that the bus is late today, now what that means is given that the bus is late today, that's this arm, so we're sitting here at this point, draw a tree diagram showing all the possible results for the next 2 days. All right, okay, so we've got, this is sort of today, and this is the next day, day 2, and then we've got another one, which is day 3. Okay, so here we've got late, not late, late, not late, late, not late, late, not late. And remember, if it was late on the day before, then it's 0.6 probability. So it was late on the day before here, so it's late here and late there, so that's going to be 0.6. 0.3 otherwise, so that's 0.6. Remember, this must be 0.4. Not late the day before, so it's only 0.3 chance of being late, so that's 0.7. Whereas this one is going to be 0.6 again, 0.4, 0.3, 0.7. So there's our tree diagram. This is day 1, and this is day 2, and this is day 3. Okay. Find the probability that the bus will be late on both of the next 2 days. In other words, it's going to be late followed by late. Okay, so it says that the probability, don't forget, we're only dealing with the fact that the bus is late on the first day. So actual fact, we're only dealing with this half of the diagram really. So you may have only drawn that half of the diagram, in which case that's absolutely fine. This half of the diagram actually is not really required because we're only dealing with a situation that it was late today, and all this stuff is we're not interested in. Okay, so the question A was draw the tree diagram. B, find the probability that the bus will be late on both of the next 2 days. So that's basically saying we're going to be late here and then late again late and late. So we need to multiply them. So the probability of being late on day 2 followed by late on day 3 is 0.6 times 0.6, which is 0.36. And C, find the probability that the bus will be late on one of the days, but not late on the other day. So one of the days, so the probability of late on one day only. Well, we can either be late on the day 2 and not late on day 3, or we can be late on not late on day 2, but late on day 3. Okay, so what's the probability of being late on day 2 and not late on day 3? So that's, if I take off these purple lines. So this situation is we're late on day 2 times not late on day 3. So that's 0.6, sorry, times 0.4. Or, so that's the green. And then the pink is either we can be not late on the first one, but late on the second one. So the pink ones are going to be 0.4 times 0.3. Okay, so just do this. 6 4 is 28, so it's 0.28. 3 4 is 12, so it's 0.12, and add them together, and we get 0.4.